10, 9, 8, 7, 6, 5, 4, 3, 2, unité, top décollage. Les paramètres bord sont normaux. Bon fonctionnement des moteurs du premier et deuxième étage. Stabilisation du lanceur sur les 3 axes.
Well, fine shots. Always impressive no matter how many times you see Soyuz powering into the sky. 309 tons at liftoff. That's less than half the mass of Ariane 5. The boosters are the first stage. The boosters on the central core or second stage are burning now,
Les paramètres bord sont conformes à l'attendu.
As the DDO says, all is well on board. The boosters weigh 45 tons each at liftoff. Total mass of the first stage, 178 tons. Their engines running on liquid oxygen and kerosene. The same propellants used in each of the 3 lower stages.
Les paramètres propulsifs sont conformes à l'attendu.
The second, or the core stage, similar to the boosters, its ignition occurred on the launch pad. As you saw, the stage will burn for 4 minutes. Remember, Soyuz weighed 309 tons at liftoff after separation of her boosters, which you may be able to see by with the naked eye, but there's the onboard camera showing what it looks like.
Séparation des 4 propulseurs.
At separation of her boosters, she's down to 135 tons. So in less than 2 minutes, she loses more than half her weight. On the bottom of your screen on the left, our altitude, on the right, our speed. These figures coming in from the downrange stations. Galileo in yellow on the screen, on the left just disappearing. That's the local station here in Kourou. The data are received by the Russian teams in the launch center, then confirmed before being broadcast. Next up is jettison of the fairing. That's in about 20 seconds. Fairing measures 4 meters in diameter, stands about 11 meters tall. We can get rid of it now in 17 seconds because we no longer need the protection it gives the satellites during their ride through the Earth's atmosphere. At 100 kilometers up, we are out of the dense layers of the atmosphere. There's no more friction, no more heating, which can disturb anything to disturb the satellites. And there you see the fairing jettison. There's another half which is out of camera range on the port side of the vehicle. This powered phase of Soyuz's first 3 stages will last about 9 minutes. Then the upper composite, called the frigate, that's the upper stage, with the satellites, will be separated. It takes over and does the rest of the work, completing the mission. Europe's space effort is a 3-way affair. Arianespace marketing and operating the launch services and the Ariane program. The European Space Agency funding new programs. And the French Space Agency CNES overseeing coordination of all space-based operations. Marianne Claire, you heard her here just at the beginning of the broadcast, new director of the space base since a month, roughly, and also the first woman to hold the role.
Confirmation de la séparation des 2 demi-coiffes.
The CNES site here, chosen in 1964 because of many advantages, not least among them a large opening on the water. We have 50 kilometers of coastline, which makes possible flying both north and east, north for sun-synchronous orbits like tonight, east for geostationary orbits. Coming up on separation of the second stage. There you see what it looks like on the animation and what it looks like on the onboard camera. 186 kilometers up. And we will have ignition of
Allumage bloc
the
I.
third stage. The DDU has just called that out.
Séparation
One
bloc
unusual
A et
aspect
inspection.
of the Soyuz, whereas with Ariane, for example, we separate the lower stage before igniting the upper stage, Soyuz does the opposite. The third
Largage
stage
section arrière confirmée.
is actually ignited 2 seconds before separation of the second stage. The reason being, the lower part of the third stage, called the skirt, is used to channel the flux of this third stage motor ignition down toward the stage below, where it rebounds, giving an added thrust, assisting separation. The third stage skirt is then separated 10 seconds later, and during those 10 seconds, Soyuz climbs 4 kilometers. In an older version of Soyuz, without the frigate upper stage, it's the third stage, which put the satellites into its initial Earth orbit. Our next film, and the first on our passengers, coming up on Cosmos SkyMed second generation.
Hi, I'm Véronique Loisel, and I am the Program Director for Cosmos SkyMed second generation at Arianespace. My work mainly consists in interfacing with our customer for all subjects linked to technical matters, but also contractual, communication, financial, insurance, and legal aspects. Our job is to respond at best at our customers' requests. As for Cosmos SkyMed second generation, the 2,205 kilogram main satellite was manufactured by Thales Alenia Space in Italy for the benefit of the Italian Space Agency and the Italian Ministry of Defense. It is a dual system, civil and military, designed to address the requirements of both commercial and government customers, as well as the scientific community. Cosmos SkyMed second generation will be part of a constellation of 2 satellites, which aims at providing an enhanced quality of the imaging services to the end customers with respect to the current CSK constellation. Thales Alenia Space is a very important customer and partner for Arianespace. Indeed, Cosmos SkyMed second generation represents the 162nd satellite manufactured by the company and to be launched by Arianespace. It will be also the 4th satellite to be launched for the Italian Space Agency and the 9th for Italy, comprising ASI, Italian MOD and Telespazio.
You may have noticed that since the start of the mission, events are announced by the DDA with maybe a slight 1-2 second delay with the pictures you see on the animation. This is quite normal, nothing to be alarmed about. The information, that's telemetry and radar, coming into the ground stations, then sent by them here to Jupiter, have to be first confirmed by our Russian teams in Moscow. Then they come to French Guiana at the CVI, which is the Quick Look Telemetry Center, which relays them to the DDO here. So at certain moments there might be a short time lapse, nothing abnormal about that. We will be going up to the CVI for a visit later in the broadcast. The Soyuz we're using today, it's the most recent version, the Soyuz 2. Originally, you might recall, Soyuz was a missile called the R-7, the world's first intercontinental ballistic missile, ICBM, developed in 1953 by Sergei Korolev, who was the father of the Soviet space program. The Soviet R-series was modeled on the German V-2. On October 4th, 1957, R-7 put in orbit Sputnik, you will recall. There's the separation of the third stage. See what that looks like. And with that, we have come to the end of the first part of the powered flight phase. We're now awaiting confirmation of the first frigate burn. Saint-Hubert at the top of your screen. That's our next downrange tracking station. It's
Extension du troisième étage et séparation du troisième étage.
We're waiting for confirmation of the first frigate burn. There will be 7, remember. Some will take place during the break, so we won't see them. We're going to cut away twice at 2 moments during the broadcast. We need 7 burns because we're launching 5 satellites, and although all are headed toward a sun-synchronous orbit, each has to go into its own orbit, of course, and its own altitude. And an interesting mix of satellites for this mission, multiple mission tonight. Cosmos SkyMed, Earth observation, the scientific mission CHEOPS for the European Space Agency, and then in the final part, of the broadcast's 3 CubeSats, small ones, OPS, SAT, EyeSat, and Angels. We'll be describing each in turn. There you see, right on time, the first ignition of the frigate burns, coming at 470 kilometers up, roughly. Our speed, 6.2 kilometers. This first burn will last 11 minutes. The second burn will take place at +1 hour into the mission, and the third 51 minutes later. The frigate upper stage, produced by NPO Lavochkin, prime contractors. Mass at liftoff 6.3 tons, carries almost as much in fuel, 5.3 tons. The frigate stands 1.5 meters tall. Frigate is an autonomous, flexible upper stage, relatively recent addition, qualified in 2000. It has been designed to operate as an orbiter and thus extends the capability of the Soyuz, giving her access to all orbits, low Earth orbit, sun synchronous like tonight, medium Earth orbit, GTO, GEO, and escape orbits. It's independent from the lower 3 stages, since it has its own tracking telemetry systems, navigation, and guidance. During the film, we were picked up by our next downrange tracking station, that's Saint-Hubert in Quebec. Soyuz heading north were no longer being followed by the Galileo station here locally in French Guiana. We're out of range. Saint-Hubert, located outside Montreal, the Canadian Space Agency has its mobile servicing system operations complex there, all kinds of training and tracking facilities for space operations and support. As we look at the Cosmos SkyMed team, their satellite will be separated in about 8 minutes, plus 12 minutes, I should say, plus 22 minutes, 44 seconds. Cosmos SkyMed is the 4th satellite to be launched by Arianespace for the Italian Space Agency, ASI. The 3 others, 2 were launched on Vegas, that was Prisma, and Lares on the very first Vega mission, and Athena Fidus went up on an Ariane 5. Our next film on the first passenger will give you an idea what the satellite will do once it's in place. Approaching separation of Cosmos SkyMed. Cosmos SkyMed you can see on the left of the vehicle. The 9th satellite to be launched by Arianespace for Italy. 2 more Italian satellites to be launched in the Arianespace backlog. There will be a CSG-2. There's also an auxiliary payload. CSG-1 built by Thales Alenia Space, the 161st satellite launched by Arianespace, manufactured by the group. And there you have the scheduled separation. We're waiting for the DDO confirmation. Again, we mentioned the slight
fin de manœuvre d'orientation au profit du satellite haut Cosmos SkyMed.
Before we get confirmation, always a moment of high concentration in Jupiter and around the world, as at all the posts, the teams are monitoring their satellite. Separation, of course, marking an end as well as a beginning. But some of the Cosmo SkyMed team has been on the project for years. For others, work will be just beginning.
Confirmation de la séparation de la charge utile haute Cosmos SkyMed second generation.
All right, and you see the DDO confirming. And you hear the applause. The first good news of the night, Soyuz successfully separating her first passenger, the 2.2-ton Cosmos SkyMed second generation 1. For the Cosmo people, you can see their smiles, a moment of triumph, watching their satellite leaving the mothership on its way to begin life on orbit. The satellite's early orbit maneuvers will take 1 week. In-orbit testing will be completed by next March. Start of operations scheduled for June.
Thanks to space telescopes like the International Hubble mission, we know there are some 2 trillion galaxies in the observable universe, and hundreds of billions of stars in our galaxy alone. Now technology is revealing planets orbiting many of these stars, and we're beginning to understand what they're like. In 1995, Michel Mayor and Didier Queloz from the Geneva Observatory co-discovered the first ever exoplanet orbiting a Sun-like star. This year, they won the Nobel Prize in Physics for their work.
In these days, I was using a technique that we call radial velocity, which is observing a star and looking for any change of speed in the star. Well, since then, the field has just exploded. As you may know, there is really now thousands of exoplanets. There are a lot of planets known to be transiting, which means the planet goes right in front of the star. And that's these techniques that we're using for the CHEOPS mission.
Thanks to ground-based observations and planet-hunting missions such as CORO and Kepler, more than 4,000 exoplanets have now been discovered. They range from small rocky planets to gas giants larger than Jupiter. CHEOPS will be targeting known planets between the size of Earth and the icy giant Neptune, which has 4 times our planet's radius. The mission will probe the nature of these exoplanets and begin to answer questions such as whether any of these alien worlds could support life.
CHEOPS's aim is to measure the size of already known exoplanets. So it's not a discovery mission. It is really aimed at precisely measure the size. And once we have the size and possibly the mass, we can derive the mean density, and from then we know a little bit what the planet is made of.
Data from the orbiting space telescope will be processed in banks of computers at the Geneva Observatory, home to the CHEOPS Science Operations Centre, where scientists will also decide which exoplanets to target.
We're sending the observation program to the Mission Operations Center in Madrid, where then the information is uplinked to the actual instrument. The instrument is configured to observe the star, and then the telemetry, the data is downlinked to the Mission Operations Center and right away forwarded to us here in Geneva, where we then can do the data processing, archive the data, and then provide it to the scientists all over Europe and to the world.
By making repeated observations of several hundred planets, CHEOPS will provide an important insight into the inner structure of exoplanets, how they form and evolve, and whether any are even a little bit like the Earth.
The first film talked about 4,000 exoplanets, I think, have already been found. I can think of a couple of the many, many missions. There was a CNES mission, CORO, a couple of years back, a couple of NASA flights, Kepler and TESS. What will CHEOPS do that all these missions and all the other telescopes discovering from the ground, as you mentioned, have not been able to do? I guess the question is, what makes it special?
It's a very good question. The missions you mentioned before were all designed to find planets. And the way they did this was to use transit photometry, technique we've talked about earlier. Yeah. And they stared at fixed points in the sky for days, months, even years, looking for the transit of these exoplanets. What CHEOPS is a follow-up mission. And what we will do is to follow up on known exoplanets. So exoplanets that are orbiting bright stars. We know when and where to point, and that's key. We look at bright stars so that we can measure the mass from the ground. And by combining the mass with the size, and from the size we get the volume, we're able to say something about the density, make a first measurement of the bulk density of the planet. And that's a first step characterization. We also have the potential to identify targets which are particularly special to be followed up with future missions, planets which have thin atmospheres, perhaps like the Earth.
Our last film on CHEOPS now, a look at the Operations Center in Spain.
An antenna at the National Institute of Aerospace Technologies, INTA, on the outskirts of Madrid. This will be CHEOPS's primary connection to the Earth, a vital link between the Space Telescope and mission scientists. Over the past year, the international team at the CHEOPS Mission Operations Center has been preparing for launch, training for in-flight activities, including commissioning, commanding and monitoring the satellite, as well as testing communication systems to ensure the smooth flow of scientific data.
We actually don't train ourselves only for the standard or expected situations, but also for unexpected situations and real problems that may happen. So that's the reason why we have two shifts, and we try to create problems for the other shift so that they don't know what's going to happen in the simulations, and then we fake that something wrong is happening and they have to find out and of course sort it out.
In the critical phase shortly after launch, when CHEOPS is safely in orbit 700 kilometers above the Earth, the mission operations team will ensure the satellite is in good health before switching on its telescope.
During this time, it is important to have more visibility of what is happening in the satellite. So ESA will provide more ground stations. So instead of just 4 or 6 passes, 6 times you see the spacecraft during the day, you will have one contact with the satellite each 100 minutes. So it's more easy to see that everything is okay and to solve any problem. That's why during this phase we will send commands not only from the routine ground station but also from ground station from the Antarctica, from close to the North Pole.
Everyone at the Mission Operations Center is planning for a smooth mission, but the team will be well prepared for any surprises.
Yeah, thinking of surprises, you've been project scientist for 6 years. I imagine in that time you've been faced with some challenges. Are there any that stand out?
A very interesting challenge that we had was on the ground segment, which you heard a little bit about now. This is used to control, operate, talk to the satellite, and collect the data. It's sort of everything that's on the ground apart from the satellite. The complexity was that there were 6 different teams working on the ground segment. The science operations team in Geneva, that you heard about, the instrument team, the mission operations center, the Airbus, the satellite providers, and also ESA.
So how many people in all?
That was six different teams.
6 teams. How many people?
Oh, more than
Lots.
30 people.
Okay.
And the final details for each of the different elements were coming at different times for the projects. People needed them at different times, but the information was coming a little bit out of sync. And it was not always convenient for everybody, nor easy to work with, but we got there and we have an efficient ground segment now.
Great. How would you say CHEOPS fits in with the overall ESA scientific program, which is very vast?
CHEOPS is the first of 3 missions that ESA will have to explore exoplanets. The next is Plato, which is foreseen to launch in 2026, and will find and characterize terrestrial-like exoplanets.
That's a discovery mission.
It's a discovery and a characterization mission. And what it'll look for in particular is planets that have a surface temperature which is that sufficient to find water that's in a liquid form at the surfaces. There'll then be Ariel, which is foreseen to launch in 2028, and that will do a dedicated survey of the atmospheres of about 1,000 different planets, looking for the molecules in the atmospheres.
Okay, let me just interrupt you briefly. As you can see on the screen, we've had our 4th frigate ignition. We're right on target at 710 kilometers. This is a short burn of less than 1 minute. The frigate is positioning CHEOPS, your satellite, Kate, for separation in about 3 minutes. And in just about a second or 2, you will see the engine shut down. There you are. So we've had our 4th burn. The DDO should confirm that. So we are approaching the big moment. So you're probably full of suspense, so I'll keep you talking so you won't be thinking about the suspense. The satellite's lifetime, 3.5 years. That's not long. What are you going to do in 3.5 years?
Well, it may not sound like a lot of time, but we're going to do a lot in that, in those 3.5 years. We hope to observe about 500 exoplanets. Some will be very well known. Some are placeholders for future discoveries, including targets which will come from tests or other surveys from the ground.
Placeholders meaning?
Placeholders meaning that we have some time reserved to insert those new planets into the schedule.
Okay.
So we'll be following up on some that you may have already heard of. For example, 55 Cancri E, which is a very hot, small planet. It's hot because it has an orbit which is very close to its host star. We don't know what it's made of yet, really. Is it rocky, lava even? And also then HD 97658b.
Why do they have these names? I mean, can't they be called Mary or
They come from catalogues, and it's a catalogue number, similar to a telephone number, one could say, a way of identifying the stars. This target is a small mini Neptune-like planet, so it's a scaled-down icy planet. And lots of follow-up. We're a follow-up mission. We'll study the clouds in atmospheres of very close-in puffy Jupiters, possibly find new planets, even exomoons or rings like those around Saturn, although that will be tough. So let's see.
All right, we have about a minute before separation. Let's talk about the data that you're saying that we'll get from the satellite. It will all be made public, I imagine?
Eventually. In the first instance, it will go to the people who proposed to make the observation. So the consortium in most cases, but then also scientists from the community who proposed to do their science. After about a year and a half, the data will then be public, and it will be available through an archive at Geneva.
Available to anyone? Imagine I'm a scientist, I'm outside the consortium. Can I get access to the data?
Anyone can access the data, indeed. It's free for everyone.
Okay. You're due in just about a minute for separation.
Maybe I can say something about the guest observers program. We have a program which enables scientists from outside the consortium to use CHEOPS to do their exciting science. They can choose to observe whatever they wish to do. It's up to them, providing it's somewhat different in choice of target from those chosen by the science team. So it's a very nice opportunity for people to make use of the exciting capabilities of CHEOPS.
All right, any researchers out there want to use the data, contact Kate Isaac at the European Space Agency. Meanwhile, we have 20 seconds before separation of your satellite. What's going through your mind right now?
Oh, quite a lot, actually. It's interesting thoughts, how we've gone from ideas to paper to metal to launch in a period of, well, more than 6 years before I even started on the project and thought of what's to come. Very exciting.
It is very exciting. We have the scheduled separation of CHEOPS. You saw it on the animation, but we're, of course, waiting for confirmation by the DDO. Again, remember the information, a slight delay, because it has to come halfway around the world. Separation of CHEOPS, the moment that we've been waiting for. It's always a very, you don't want to say stressful moment, but it's a concentrated moment before satellite separation.
Confirmation de la séparation de la charge utile CHEOPS.
Woohoo!
The applause you heard was Kate Isaac clapping into her microphone. She has a big smile on her face. A big moment for you.
Yeah, that's very exciting. It's very exciting indeed. And the next few days are going to be very interesting. We're going to be working at the Mission Operations Center to check out the spacecraft, and then once that's done, everybody will have a very well-deserved Christmas break. And we're back in the new year to exercise the instrument and also the science operations team. Check that the instrument has survived the launch, to see how it performs, and look to see then how we're going to actually command the instrument and process the data, which is the end product that we're all very much looking forward to getting.
Well, congratulations to you, Kate. Just a final, we are going to have to cut away just a final very quickly, a message to the team out there.
Very big congratulations and thanks to the very many people in the consortium, in Airbus, across our industrial partners, and as well, of course, here at CSG and ESA. Really looking forward to receiving the data that we'll get, and yeah, amazing.
All right, very good. Day. We're due to pick up the signal from the Troll station. That's Antarctic or Arctic?
Arctic.
In the Arctic city. Okay. For more on CHEOPS, we're going now to Dominique Detain of ESA. That's he's your colleague, who has a special guest. Kate and I will be back for some final words.
Nice to meet you again for the next step of the mission, that is the separation of the three auxiliary passengers Angels, EyeSat and OPSAT. The first one, Angels, Argos Neo on a generic economical and light satellite, is the first made-in-France nanosatellite. Angels is a 12U CubeSat. It is jointly financed and developed by the French CNES Space Agency and Emiria, affiliate of Nexeia. The satellite is fitted, among the others, with a miniaturized Argos Neo instrument, which is 10 times smaller than the equivalent previous generation device. Being the payload developed by Thales Alenia Space and Sirlings, Angels will join the current constellation of Argos instruments. The second one is EyeSat, a student CubeSat which belongs to Janus, Jeunes en apprentissage pour la réalisation des nanosatellites des universités et des écoles de l'enseignement supérieur, a CNES program that supports French universities in developing their CubeSat projects. The specificity of EyeSat is that it has been developed within the French Space Agency since 2012, with more than 250 students involved. EyeSat, a 3U CubeSat, is equipped with the small homemade telescope IRIS and will observe the zodiacal light. The third one, OPSAT, will be the first satellite launched by Arianespace for TIVAC on behalf of ESA. TIVAC offers access to space by providing end-to-end cost-effective space systems using agile aerospace processes and accelerating on-orbit access. TIVAC International of Italy provided the deployer and launch service for OPSAT on behalf of ESA. OPSAT was developed by the Graz University of Technology with subcontractors from Austria, Germany, Poland and Denmark. It is operated by ESA from the European Space Operations Center in Germany. I would like to thank all the teams involved in this mission for their professionalism and spirit of cooperation. Thank you.
Well, 2/3 of the mission have been completed. OPSAT and EyeSat are our next passengers, but not our last passengers. They will be separated together at +4 hours and 10 minutes. That's just 14 minutes away. OPSAT is a CubeSat and the first satellite to be launched by Arianespace for the TIVAC International of Italy. I hope I'm saying that right. It might be TIVAC of Italy, on behalf of the European Space Agency. It arrived here in French Guiana November 27th. It was assembled on the platform along with Angels and EyeSat 3 days later on the 30th of November. They are calling it the first free-for-use in-orbit testbed for new software, applications, and techniques in space control measures. And now a film on OPSAT.
OPSAT is a tiny CubeSat, just 30 centimeters high, but containing an experimental computer many times more powerful than on any current ESA spacecraft. It's the world's first mission dedicated to testing satellite operations technologies, software and techniques in the harsh environment of space. To develop innovative new software for future missions, testing must ultimately be performed in orbit. Experimenting with operational satellites is too risky, too costly, and failure is never an option. With OPSAT, failure is an option, as the satellite can be recovered and rebooted after each experiment, enabling developers to learn from their mistakes. This flying laboratory will be controlled from a new small footprint lab at ESA's ESOC Mission Control Center in Darmstadt, Germany. Here, engineers, students and the European space industry can come and test their new mission control software and concepts in space. By taking control of a satellite in orbit, their experiments can go far beyond the limits of what is possible on the ground. Over 100 companies and institutions from 17 European countries have already registered experimental proposals to fly on OPSAT, demonstrating the mission's value to the spaceflight community and industry for innovation and experimentation.
Turning to EyeSat, the 16th satellite launched by Arianespace for CNES, the French space agency. Angels will be the 17th. The others, by the way, include the Spot Series 1 to 5, Topics Poseidon the Ocean Observer, 2 Pleiad missions by Soyuz in 2011 and 2012. With Angels and CHEOPS tonight, Arianespace has launched 130 missions and 159 satellites for European institutions and 7 countries. So Arianespace at the service of European space science. EyeSat with 3 objectives. It'll observe zodiacal light, that is the phenomenon of sunlight scattered and reflected off dust particles. It'll demonstrate new satellite technologies, and it will train students in space engineering professions. To do this, it carries a small space telescope, weighs about 4 kilos in orbit. Over to a film on EyeSat now. You'll be hearing from CNES President Jean-Yves Le Gall.
Hello. With the launch of Angels and EyeSat, CNES is proving once more a pivotal player in launches, satellites and applications, the 3 main sectors of space. This launch underlines the fantastic versatility and flexibility of the Guyana Space Center, capable of launching all kinds of payloads. One of CNES's 4 centers of excellence, the CSG, is among the most sophisticated and effective launch bases in the world. And it is set to stay that way after the historic decisions regarding Europe's space program on 27th and 28th of November in Seville. Angels and EyeSat also illustrate CNES's impressive ability to innovate. Angels, a demonstrator for the first series of French commercial nanosatellites, was designed, developed and built in a little over 2 years, thanks to a unique partnership between several French SMEs. It is carrying the highly miniaturized, low-cost Argos Neo instrument, the latest in line from the famed Argos family. With Angels, we are thus moving into the burgeoning commercial nanosatellites market. EyeSat, meanwhile, is serving our ambition to pursue in-depth educational projects with students from engineering schools and universities and prepare them for careers in space engineering. Together, these 2 missions are opening up the field of space applications, especially for the Internet of Things. The future Kineas constellation of nanosatellites derived from Angels is set to serve new applications for agriculture, logistics, fisheries management, sea rescue and more. Just days after the Seville conference, whose historic decisions marked a giant leap forward for Europe, CNES is showing once again with Angels and EyeSat that it is at the cutting edge of innovation and continuing to lead the way forward.
CNES President Jean-Yves Le Gall, of course, former head of Arianespace. We are coming up on the 6th frigate motor ignition due in about a minute. That'll be a short burn, 20 seconds roughly. All 5 satellites tonight going into sun-synchronous orbit. This is a low Earth orbit, around roughly 700-800 kilometers. What happens is the satellite circles the Earth over the poles, constantly moving with respect to the Earth, unlike geostationary transfer orbit, for example. and it passes over the same point on the ground at the same time, so that the images are always acquired in the same light conditions. Couple of numbers. Today's mission, the 315th launch for the Ariane family. The 5 satellites tonight are the 647th, 48th, 49th, 50th, and the 651st satellites launched by Arianespace. And you can see the frigate has lit its motor for the 6th time. There will be one final burn, but we won't see it. Comes after separation. And there is the cutoff of the engine. You saw it shut down right on time. We said it's been a busy year for Arianespace. Just a quick recap of 2019. 9 launches in all. Before tonight, 4 Ariane 5 launches, flights 247, 248, 249, and 250 just last month. Ariane 5 carried 8 satellites this year into orbit, all of them telecom satellites. There were 2 Soyuz missions before tonight. Flight 21 with 6 OneWeb satellites, and Flight 22 with 4 O3b satellites. And there have been 2 Vega missions. Flight 14 with Prisma for the Italian Space Agency, again like tonight, and Flight 15. So 25 satellites in all, not a bad showing. Telecom's Earth observation missions, the Prisma demonstrator in March, and the CubeSats. We go to a film on EyeSat next, and separation coming up afterward. Don't go away.
Sixième allumage et sixième extinction du moteur frégate au profit du
This is EyeSat, a CubeSat-class student nanosatellite designed to study the zodiacal light and the Milky Way. This nanosatellite is a pilot project spawned by the Janus program, initiated by CNES in 2012 to get students at French engineering schools and universities interested in space. We need to train young students through internships. We take in more than 150 interns at CNES every year. We get them working in project conditions like real engineers, so it's very instructive. To develop the EyeSat system, CNES worked with 3 partner engineering schools, INAC for the ground receiving station, ISAUT Super Aero for the development and operation of the control center, and the IUT Kashan Technology Institute for the mechanical and electrical elements of the payload.
We know that everything we build is going to be flown and operated in space, so it's amazing to get the chance to work on something like that.
EyeSat is carrying 10 innovative technologies that are the result of CNES's research and technology efforts and developed in partnership with industry. It nevertheless remains a resolutely scientific mission. We survey the sky to acquire images of the Milky Way and of what's called the zodiacal light, which is a tenuous light created by sunlight reflecting off interplanetary dust grains. The LATMOS and IRAP research laboratories that help to define the EyeSat mission will be tasked with exploiting data from the satellite. Janus is proving successful in training future space engineers and nurturing entrepreneurial talents, since 5 startups have so far been created as a result of the initiative. I've really been able to gain a great deal of knowledge spanning every aspect of space systems that enabled me very recently to start a new company, which is going to be a CubeSat prime contractor, where we'll be using everything we've learned from EyeSat.
EyeSat and OPSAT both due for separation in 4 minutes. Turning to our 5th and final passenger, Angels, due for separation in 7 minutes, or 4 hours and 13 minutes into the mission. It is the first nanosat, CubeSat, built by the French industry for CNES. It arrived here in French Guiana on October 16th with CHEOPS. The generic economical, I should say, and light satellite Angels, financed and developed by CNES and the Hemeria Group, I believe of Toulouse. Basically an advanced miniaturized location data collection and data relay demonstrator. Now it's fitted with a very small Argos instrument, we're told 10 times smaller than the previous generation. Argos, you might remember, a satellite system which collects and disseminates environmental data from platforms in over 100 countries, I think over 20,000 transmitters in all. Teams from CNES, Hemeria, Thales Alenia Space, and the French Sirlinx group all worked together on the project. Our final video tonight, a look at our final passenger, Angels. We'll be back for separation of OPSAT and EyeSat.
This is Angels, the first commercial French nanosatellite designed to collect and locate signals and messages from the 20,000 Argos transmitters around the globe. Developed by CNES and Toulouse-based firm Ameria, it's a great feat of technology, despite standing only 35 centimeters tall and weighing as little as 18 kilograms.
Nanosatellites are also a development philosophy based on building faster and cheaper while taking a little more risk. And for a firm like Imra, it's all about finding the right trade-off between cost schedule and the amount of risk the market is ready to accept.
Ameria was selected after a CNES request for proposals in 2016, geared towards taking France into the growing commercial nanosatellite market.
CNES is engaged in this endeavour to support the network of small firms in the region and nationwide, and to meet this new demand from the market.
To this end, CNES and Ameria have adopted innovative ways of working, setting up a project platform with more than 25 people, including 5 engineers from CNES, and using short, iterative development cycles to improve the design and production phases. CNES has also brought Ameria its research and development expertise.
We've been able to draw on expertise in all fields, from materials and thermal analysis to management of the flight-ground systems interface and the control center.
With Angels, Ameria is therefore on track to build the future CNES constellation of 25 nanosatellites, planned for launch in 2022 and designed for the Internet of Things. I can't wait to see it in orbit with the Argos Neo payload. Angels is expected to deliver data for 2 years.
A little over a minute until separation of OPSAT and EyeSat, both launched here from the CSG, the Guyana Space Center, the world's only dedicated commercial space base. The base was chosen back in 1964 among 14 possibilities, including Australia and Scandinavia, when the Europeans wanted a new base. They found everything they were looking for here. We mentioned a large opening on the ocean, but that was not all. They wanted a low population. I think even today, 270,000 people in French Guiana. Most of the land is forest, as you may have noticed. They wanted nearness to the equator, which allows a launch to benefit from the Earth's rotation to get more quickly into orbit. The Earth spins and adds 400 meters a second to a launcher getting into space. The site here also free from hurricanes and earthquakes. We're south of the hurricane zone. It also offers hills nearby where radar and telemetry facilities can be installed to follow the launcher, and that we're going to see in just about 2 minutes because we're going to go up to that facility. Meantime, we await confirmation of separation of EyeSat and OPSAT. Again, a moment of high concentration here in Jupiter, and I imagine at all the EyeSat and OPSAT facilities around the world. The animation you see together, separated, one on either side, OPSAT and EyeSat, but of course we're waiting for the official confirmation from the DDO. That shouldn't be long in coming. These dedicated teams who've worked so hard on their projects, following the final moments. Again, awaiting word from the DDO that their satellite has successfully separated from the frigate vehicle, just like CHEOPS before, and Cosmos SkyMed before that. Jupiter Mission Control, we mentioned, it's like a control tower of the space base, like an airport, and the brain of all launch operations. One other place, and the last one we want to show you, where the teams are hard at work tonight, we mentioned, this is the CVI, Quick Look Telemetry Display Control Center. And the DDO has called out confirmation of separation of OPSAT and EyeSat. And you hear the applause. So that's good news. Meanwhile, we're looking at the Quick Look Telemetry Display Control Center. It's on a hill just behind us here in Jupiter. Remember, when choosing a space base, the Europeans wanted nearby hills for radar and telemetry reception. These teams have all the means for receiving and processing, storing, and analyzing all the data coming in every second from the ground stations along the Soyuz flight path. Remember, we've been talking about the stations that follow the launcher. The Canadian station Saint-Hubert, Mauritius, which you just saw, we've been picked up by that antenna. 2 antennas over there. Right now, these teams are monitoring all the key flight data they are receiving and are reporting the flight status of the launcher back to the teams here in Jupiter. Also to the flight desk and to the Launch Complex Operations Manager. All part of the great information flow from points all across the base back in here to Jupiter. You see how Jupiter deserves its name as the nerve center of the space base. Separation of Angels, our final passenger, in just about 6 seconds. The Angels people, just like the OPSAT and CHEOPS people before them, all eyes on the computer screens and ears on the telephone. There's the computer animation. Separation of their satellite. It is a small one compared to the mothership, as you see. I think 19 kilos. And the DDO will confirm that. And he has confirmed it. You see the applause, you hear the applause. The final good news. As Soyuz completes her very long and very complex mission with successful separation of Angels. So Angels joining her co-passengers, CSG-1, CHEOPS, EyeSat, and OPSAT, beginning life thanks to Soyuz and Arianespace. Smiles, hugs, handshakes all around. Here in Jupiter. Yes, very happy teams. Kisses, cigars, and champagne will be forthcoming, no doubt.
Confirmation de la séparation de la charge utile Angels.
Arianespace successfully delivering once again on her final mission of the year, 5 new satellites making their ways to their final orbit. So from the tense minute just moments ago, you can see the change here in Jupiter, very buoyant, all across the Space Center. And no doubt at the points and posts where people are following the launcher and satellites. Here's another replay of the launcher. Several launch replays for you. Work is just beginning, or soon will be, at the different ground stations for all our passengers this morning, and the other sites around the world where their first maneuvers are being monitored. We're waiting for the traditional post-separation speeches, and I see